Okay, so if you recall, last class we discussed more about stack applications. One we discussed is postfix evaluation using stack. And the second one we discussed is infix to postfix conversion, also using stack. Okay, so that's the two algorithms. So today let's take a look the program part for both of this algorithm. Okay. So in this example, it's about postfix evaluation. Oh, I also forgot to mention postfix expression. There's another name called reverse Polish notation. It's also called reverse Polish notation. A Polish mathematician proposed the postfix expression. Okay, so it's a reverse Polish notation, so RPN. Okay, that's how this RPN come from. So this example is regarding evaluation of postfix. What over here we are going to use? We are going to use the Java collections stack. Okay, so Java libraries stack, and the postfix is going to be the postfix expressions stored in a file. So we are going to read those expressions from file and apply the algorithm, do the calculation. Okay, that's how this algorithm works. So let's first take a look at all the related method. Because all the postfix is going to be stored in a file, so line by line. In a file. So suppose like you have 3, 5 plus, is it then 8 times, something like this, is it? So this is a line. And in a file then, when you read, all of this is going to be a string. So each of this, when we do scan, it's a string. But when we do the evaluation, we need a number, etc. And also we need to identify if it is an operator or number, etc. So that's why here we have this utility function called isNumber. And what is a parameter is a token. So the token is each of the string, okay. And here we separate the token using space to separate each of the token. Okay, and so we are going to find if the token is a number, and here we also take a decimal point, so not just a integer number. Okay, so for this isNumber is trying to figure out if a number is a valid decimal number. Okay, so that's why over here we are going to loop through the string, because you may have 198 something, that then and dot 99. So you will have multiple numbers. Okay, and it's a string that. So we are going to do letter by letter. So for each specific letter, then we are going to determine if it is digit. is it? Or if it is a decimal point, okay? And also if the first one, is it? If the first one, it can also take a negative number, is it? So it take care of the cases, okay? And of course, the decimal point shouldn't be more than one, is it? So if you have more than one decimal point, that means it's not a valid number. So that's why it's returned false. So anyway, this method is a utility method to determine if a token is a number. And then what to the next one we are going to do is we are going to do the evaluation, okay? For the evaluation, so this is the postfix expression. So we are going to calculate the result and return it, okay? And over here, we also use a Boolean array to see if the postfix expression is a wrong one. Because if you recall that algorithm can also give errors if it's not a legitimate postfix expression. So that's why over here we also use this to keep track of that. And for the stack type, and remember, if you use the library's stack, you need to specify the type, is it? And for the type, it must be a reference type. Cannot be primitive, okay? So always keep this in mind, okay? So this is just like the array list. We already learned, is it? Wherever you need to plug in some reference type, okay? So here we use the big double, okay? And if you recall, we need the number whenever you apply the operator to numbers. So that's why we have this. And we also have an array of string to keep track of the tokens, okay? So anyway, for each of the, so how do we get of the tokens? We use a white space, is it? So this is a string. Strings split method will return. So it will return an array of strings. So that's why here you can get of the token out. And here it's use all sorts of space, is it? And this is regular expression. If you recall, this is space. This you can have more than one space, okay? Okay, then for each of the token here, we use a for each loop. Then we first need to determine if it is a number. Is it? If it is number, then we need to convert. So this is you convert string type of number to numeric value. That we call that a parse double, okay? After you convert, then you can push to the stack because the stack is double. Okay, if the token is not a number, okay, then we need to determine if, because the operator has only one letter, is it? So yeah, so if it is a single letter, then we need to, because if you recall, so the stack is a number stack for postfix expressions. Suppose we have 6 plus 8 times something like this, then in this case, you have 5, 6, is it, in your stack. And the token, now you reach the token plus, is it, you're supposed to pop both number out, is it, both number out. So if stack, if you don't have any number pop out, that means error in the postfix expression, is it? So we can raise the flag, okay? Otherwise, if the stack is not empty, then you can get a number out, okay? Get the number out. So you pop, is it? Yeah. Okay, so this is second number, number 2. Second number. And then if the stack is empty, suppose we don't have 5, that means error in expression again, is it? So otherwise, you can get the second number out, is it? Then you apply to number 1, okay? After that, I needed to clear. After that, then we can apply the operator, is it, to the 2 numbers that popped out and converted, is it? And if the token is not one of the 4 arithmetic operators, then that means something is wrong, okay? So then we can flag error in expression again, is it? After you calculate the result, then what we can do is we push the result back to the stack. Okay, back to the stack. Okay, and so let's see so we have this within the for loop. So loop is loop through each of the tokens, and then determine if it's number or if it is operator, otherwise something not correct, is it? So error in expression again, okay. And after we finish scanning, is it? Then we just do the pick and the pop, okay, pick and pop. And also after we complete a pop, if the stack is still not empty, that also means something is wrong, okay. So then we can also record the error, okay. So that's regarding this algorithm. And then in the testing part, what we do is we are going to get the file, okay, get to the file. And then we start to get input from the file, because there are multiple lines, is it, for each of the line. So over here, we get line by line. So for each line, if it is not the last line, the end, that means this should end of the calculation. Then we are going to call that a postfix evaluation, okay. And then we can output the result, okay, output the result. Okay, so, but there may be some errors, is it? If any of the errors happens, then we just continue with the next line of the postfix evaluation, okay. So that's regarding the postfix evaluation, okay, example. And what next we are going to see is about infix to postfix, okay. And here, similar, we are going to use Java libraries stack. And this time we are also going to write the calculated or the converted postfix expression to a file, okay. So that's why here we have file writer. Then let's see, so first let's take a look at the utility function, okay. So similar, this is to determine if it's number, okay. So nothing new. And also operator, we also want to know if it is an operator. And for this, over here, we also consider left parentheses and right parentheses, okay? And then we are going to see if it's, if the token, is a one of this operator, okay? If it is, then you return true, okay? And if you recall, when we do the infix to postfix expression, whenever we have an operator, then you need to compare with the top of the stack. Is it suppose you have token? This is the stack of top of the stack. If it doesn't have a higher precedence, is it? Then you need to pop this out. Is it? And this has a higher place, so let's just push it back. Is it? If it doesn't has high, then you need to pop. And suppose over here we have multiplication, and then here we have plus. Then this doesn't have higher precedence than the top of stack. So then you need to pop this out, and then pop this plus out, and then get this plus in as that addition. So we need to determine the precedence. And also sometimes your top is left parenthesis. If it's left parenthesis, you just directly push. Okay, so that's why here we have the precedence utility function. Okay, so it says if it is left parenthesis, then you just push it as it to the stack. And if it's right, then we don't, we need to do the pop. Okay, then it says if it is plus and minus, then we need to determine if the other compared operator is multiplication or division. If it is, then that means operator 2 has a higher precedence. Okay, and over here is if it's multiplication or division, is it? Then you need to determine if the other operand is one of the case. Then you need to determine return true or false. Of the other, then I just return false. Anyway, so this utility method is just to provide support to determine who has the higher precedence. Okay, then what is the next one? So this one is to do infix to postfix expression. Okay, so over here, our infix, we use a string. So because it's from a file, okay. For our postfix, we use a string builder, okay, to keep track of it. And here, also be careful, in infix to postfix, the stack type change. The stack is a character type. So here we need to use that big character, the wrapper class. For character, okay, we don't use the primitive character type. And the same thing, we call strings split method to do the tokenization, okay. And then we loop through each of the token, okay. So if token is number, then that's simple, you just directly add it to postfix. And also we add an extra space, okay. And then if the token size is just 1, then if it is an operator also, then we need to process the token, okay. And we need to determine, okay, if it is not an operator, then there is a problem, okay. Otherwise, if it is the operator, if it is left parenthesis, we just directly push that token to the stack. If it is right parenthesis, what we need to do is you need to keep popping. Is it? So that's why over here, okay, you need to keep popping until what? Until you see the left parenthesis. Okay, the top of the stack is the left parenthesis. Otherwise, you need to do the pop. Okay, you need to get the operator to the postfix expression, and then you pop that operator out. Okay, and of course, if your stack is empty, then you cannot do the for. So that's why here we add this condition first. Okay, so this is called shortcut of that condition checking. Okay, so because once it's empty, then you even don't need to worry the following. Okay, and then because it's a left parenthesis or it's a right parenthesis, is it finally you also need to get the respective left parenthesis pop out, remove it. Okay, and if at that point your stack is empty, that means something is wrong. Your infix expression is wrong also. Okay, and what next one is the operator is one of the arithmetic operators, plus, minus, multiplication, division, etc. If that's the case, then you need to determine if the token doesn't have a higher precedence. So the token's precedence is lower than the current of the top of the stack, is it? Then you need to remove the top of the stack and add it to the postfix expression. So you need to keep doing. So that's why over here we have this while loop, okay? We need to put it in a loop. And after we complete, then we also need to push the token back to the stack, okay? And then other cases, then that means some wrong expression, okay? And after that, you also need to empty out of the stack the remaining operators and add them to the postfix expression, okay? So this is also regarding that infix to postfix expression. And then next in the testing part, what we do is we have the postfix in a string builder, okay, stored. And here is a file. And we are going to write the postfix to this file. And we enter the infix from keyboard. Okay, so here it takes your infix from a keyboard, okay? And then what we can do is we can call that infix to postfix expression, is it to convert the infix to a postfix. And after we call that, we have the postfix, then we are going to have it write to a file, okay? So this is a postfix, then you convert to string and you write it back to a file. So all your infix then will be stored in this file, postfix file. Okay, so that's regarding this infix to postfix evaluation. So basically,